Okay, we're continuing on with our prior example, but instead of solving it using present worth, we're going to go to what the third question was and solve this problem using annual worth. So we have our same cash flow diagram set up here. We have our same 15% per year. Cash flows are annual, no mention of compounding, so 15% is our time value of money. That's our minimum attractive rate of return as was stated in the problem. And we're just going to find our annual worth. So annual worth, we take our everything that all the costs we have, all the investments at time 0. So if you were to add all of these up, that adds up to $1,250K, so $1.25 million out in time 0. This is at time 0. Time 0 is not an annuity, so we need to change it. So we want to find the annuity using the functional notation, find the annuity given the present at a 15% interest rate over 10 periods. So we're going to try to take this whole dollar amount here and see what is its equivalent spread uniform over these 10 years is what this section right here is doing. Then we want to add in the $750 per year. That's already at an annuity, so that's fine. We don't need to do anything with it. Then we subtract the $475 because that's an outflow. That's also at an annuity. Same cost, $475 every year for 10 years. And then we want to take this $900, the salvage value and working capital, while we get back at year 10, and we want to find out what is its equivalent uniform annual payment over 10 years. So it's $900, that's the future. We want to find the annuity given the future at the same 15% over 10 years. So we go to our compound interest tables just like we have before, and we find the functional we find the value for those functional notations, and here we have it right here, 0.1993 and 0.0493, so that's what we would multiply the present value by 0.1993 in order to find out what its equivalent uniform annual cost, in this case because we have an outflow, is over that time period. And you can see that turns out to be $70,000. And if you remember from the prior video, our present worth was also positive, I think 350,000, something like that. So both of these are giving us the same decision. As we said with present worth, if present worth is greater than or equal to 0 at the stated MARR, then that means we're meeting that hurdle rate, we're meeting that minimum attractive rate of return, and we would move forward with the project. That same statement goes whether we're talking about present worth or annual worth or future worth, any of them. They're all measures of profitability, and regardless of how you solve the problem, they will give you the same decision. So here we have our annual worth is greater than 0, so we know that we've beat our MARR of 15%, and we know that we would go forward with the project. So the same answer we had in the present worth format. Now let's do one other thing. Let's see, let's scroll down here and do one other thing. Could we take our present worth of 352 that we found and convert it to an annuity, and what would it be? So we have our present worth of 352. We find the annuity given the present, 15% over 10 years. We find that factor from the tables, which obviously is the same as what we had up here. And surprise, surprise, it turns out to be $70,000. So no matter how you go about it, the annuity is going to be $70,000 positive. We could have done the same thing, taken the $70,000 and converted it back to a present worth, and it would have been $352K. So the decision is the same whether we're looking at annual worth or present worth. When that is positive or greater than 0, then we move forward with the project. I hope that helps explain equivalence a little bit more, and now we're getting into evaluating projects. Thank you.